So we've created a conceptual line design or layout, and now we want to test that before we get too far down the road with creating a detailed CAD layout, or even worse, a physical implementation where we have to make changes later on. So what we're going to do is take our conceptual line design and model it, create a model and run the model. And we're looking for a number of things like utilization, but primarily we're looking at throughput. So we designed this line for 274 units per day. Let me remind you of that. And that day was 840 minutes long. So we want to make sure that at least in this model we can achieve that goal. So here's the data file for this simulation model using the Lean Design Simulator. So we have our, I'm calling it VSM, that's our flow. And we have resources. Those are the resources that we calculated. You may recall we had 1 cut, 2 frame, 3 final, 1 pack, 2 ship. And that's what you see here. And then we have a labor resource. We're calling it op final. And we have 7 people allocated for that work. We're keeping things very bare bones for this first run, so we haven't put in any IPKs. The variability is set to high, meaning the times aren't always the same, they vary. But we can run experiments and change those values. The flow tab, the flow worksheet, just simply indicates the flow, which processes are connected to which. So cut goes first, and it's connected to frame 1, and so on and so forth, all the way to ship 2 at the end. The products are what we saw earlier in the line design worksheet. So we have 5 different products, org 1 through org 5. The processing times are what we saw in the line design worksheet, but it's formatted a little bit differently. It's more in a matrix format, but they're exactly the same times we used in our static line design or resource calculation worksheet. This is where it gets a little bit complex because for every product and every process, I need a time. But if we reorganize these, you'll see the matrix that we had earlier. And then sequence is our production plan. Again, we're keeping it very simple for this first experiment. So I'm simply going to run a batch of 10 of each of these organizers. 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, etc., and see what we get. But the sequencing tab is one area where we want to do some experimentation to develop our sequencing rules to improve the flow. Okay, so that's it. That's our file. So let's just go right to the simulator. I've already preloaded it. And warm-up time 30, runtime 840, use variable times. And let's run it. So it's in process. Doesn't take long, does it? And we ran it for a full day. Remember 274 and we got 222. So that's not entirely a surprise because our static design didn't include factors like variability. We haven't added any buffers or IPKs to this. So we could spend the rest of the day running experiments and optimizing our design. But I just wanted to give you a taste of the value of this because without doing this kind of simulation or model building, you wouldn't necessarily know what you were going to get until you actually brought the line live, and then it's too late, especially if you have to add resources. Later on, you may not have even the space to add them. So it's way too late once you physically put the design into place if you have to make changes later on. Now, orders completed is one data parameter that we're going to look at, one output. But also, you can download a very detailed Excel file that shows by station, by resource, by product, what those simulation results are. So you can fine-tune, really zero in very quickly on the bottlenecks and where the issues are to get to that goal we have of 274, right? So we have a ways to go here in terms of improving our model, but that's how you would do it.